slides related to agent that we are going to use this week in order to discuss our point. Okay, so we already seen what is an agent. So that's the agent as we view it. Okay, so there is something called as sensors, something called as actuators. Actions are imparted and perceived comes to the agent. Okay, so that's the definition of agent. Already have gone through, so I'm just going to read through it this quickly in order that you understand if you have missed anything. Agent perceives its environment via sensors and acts in the environment with the effectors or affectors. Hence, an agent gets percepts one at a time. So that is how it is assumed. Maps this percept sequence to action. So this important thing we talked about yesterday, even though the agent is receiving a single percept at a time, it somehow represents this percept sequence that is used for imparting an action or selecting a particular action. Now, there could be different properties that an agent can have. Agent can be an autonomous agent. We said, what do you mean by an autonomous agent? If the agent is relying only on its discretion in taking the decision about which action to perform, depending on the percept sequence, then such agent is called as autonomous agent. Okay, there could be an agent that is interacting with other agents and the environment itself. So whenever I see this simplistic view of agent that I see over here, that there is an agent and the environment, I'm just talking about a single agent environment. But an environment can be having multiple agents. For instance, if I'm actually creating an agent for playing soccer as a team, then there will be actually multiple players or autonomous players, I should say, they are playing with each other against some opponent. So there are multiple different kinds of agents. Some of them are cooperating the agent for which we are writing the code or for which we are writing the AI procedures, and there will be certain agents which are actually against playing against the particular agent. So that is again very important to understand when we talk about agent. All these things we are discussing because, as I told you at the beginning of the session, that agent प्रोग्राम लिखने के लिए या एजेंट सॉल्यूशन देने के लिए सॉल्यूशन एज एन एजेंट या एजेंट सॉल्यूशन क्रिएट करने के लिए व्हाट आई रिक्वायर इज आई रिक्वायर टू डू some sort of analysis. That analysis is referred to as PEAS descriptors, where the last two things, E and S, they are something that we do analyze very quickly and identify very quickly about an agent situation. Okay, that is, we can find out what are actions, what are sensors. Okay, so actuators and sensors are well known. So once you know that, we know what kind of interaction the agent has with the thing called as environment. But then if you look closely the environment type and try to describe it, it gives us more sort of insights into what comes through those sensors, what are the percepts, how I visualize the environment as an agent. Okay, and when I say I analyze the environment and get to know that if, say, suppose agent is able to perform, say, action 1, 2, and 3, if I know how is the makeup of the environment, I would be able to understand the impact of these actions. So ultimately, as an agent, I'm trying to figure out the mapping between the percept sequence and the agent action. ओके, अगर मेरा पर्टिकुलर एक्शन इन्वायरमेंट पे क्या इम्पार्ट करेगा, क्या क्या changes in the state of environment is expected by that particular action. If an agent wants to know that, it needs to understand the environment in greater details, and that is what we do when we do the second component of this PEAS analysis. That is, we talk about environment. We try to understand the environment in greater detail, in more details. And the first component of this PES descriptor is called as performance measure, and that is the thing which makes an agent distinct from the definition that you see from over here. Because this definition over here is basically a definition of an agent, not a rational agent. But what we are striving in AI is to build a rational agent. As we already know that building an agent that mimics human behavior or thinking is always going to be not that accurate. But if we strive for making systems which are behaving rationally or thinking rationally, then we are trying to actually mimic human beings and making the system yet rational. Okay, so that's the thing, that's the theme that we have, and that's why will not be talking about just normal usual agents, but we'll talk about agents which are intelligent agents. Okay, now I'm skipping this and I'll come back to this discussion because we had discussed these things last week. What I want to start today is talk about this particular thing. So whenever I say something is an agent, it's actually a combination of two things. One is the architecture of the agent and the program of the agent. Okay, so architecture of the agent is the organization of components that goes into becoming an agent. That is the sensor, the actuator, the thinking process block, all those things. The organization of these components is referred to as agent architecture. And the program of the agent, okay, which is closely trying to rebuild the agent functionality. So what we said was the agent functionality. Agent functionality is simple. You need to map percept sequence to a corresponding action. And the agent program is something that tries to realize this functionality making use of agent architecture. So it becomes quite essential for us to first talk about what do you mean by agent architecture. Okay, so I know that some of the things I have skipped that needs to be addressed, and that is about the different properties of agent environment. But I'm going to discuss that in the second session of this week. I'm going to today start off with describing more about agent architecture. What are different kinds of organization of the components that make up the agent. Okay, that is what we are going to talk about today. And we go back and talk about the environment properties in the upcoming lecture. The reason why I'm going this way is the slides that I was showing you last week. Okay, I'm not able to present those particular slides right now, and I don't want to waste your time in me getting those downloaded and then reconstruct it into a PDF file and other things. Okay, I should have done this already, but maybe I didn't expect that this machine is going to give me certain trouble. Okay, last week there was no trouble. This week it is giving me certain trouble in sharing my entire screen. I'm not able to share my entire screen. Maybe some settings are wrong. I'll correct those settings by the next lecture. Don't worry about it. So we'll today concentrate on this type of agent architecture. Please understand. Now we are reeling from the analysis step of the agent to the design stage of the agent. So now whatever solution we are creating, okay, first we have to do PES descriptors. That is, we need to analyze what is the environment like, what is performance measure, what are sensors, what are actuators. And once that is done, we get enough ammunition with us to now go about and embark our journey in designing the solution. So this design phase is where we concentrate on defining the architectural organization, okay, the components and their organization together. And ultimately will bring out something called as an agent program. So we'll be talking interchangeably about these two things in order to realize the agent. So whenever I say agent is equal to architecture plus program, I'm talking about design of the artificial agent or intelligent agent or rational agent. Now onwards, whenever I use the word agent, it reciprocates any one of these three things. And for us, these three things are kind of same here onward in the discussion. So whenever I say agent, I'm talking about an agent which is rational in terms that it tries to map P star to A in a most efficient way. Obviously, we said that we can't be scientific, that is, the agent can't know all the alternatives using the percept sequence. Hence, we cannot have a omniscientific agent. Okay, that is pure rational agent is not possible. So we are having a rational agent to certain extent, certain best possible implementation. That is what we mean by it. So this is the program for the agent. This is how the agent program in its simplest of the form would look like. So there will be a function called as skeletal agent which will receive percept. So current percept will be received, and what it will return is the corresponding action. That is how the agent program function looks like. So program means you know what is program. So program means it's something like a code, and this is the code which will run the architecture that we are organizing. Okay, so this is the design of my agent, which is going to run a function continuously, and that function is skeletal agent, which will receive percept as input and which will return an action. What will be the components or what will be the variables that this particular function has? There are certain local variables which are static variables. So I know you would know what do you mean by a static variable. Static variable is that variable which does not change its value between the calls. So the memory which is represented by that variable, okay, that memory address is not reused, that is not refreshed as the function call ends. So I make a second call, I will remember those variables. So persistency दिखाने के लिए इस particular variable को static variable के तौर पे define किया गया है. So we are saying that memory नाम का एक static variable है. This is agent's memory of the world. So in this variable, the agent is storing or memorizing how the world previously was. Okay, so it's a memory of the agent. Now what we are doing is we are taking this previous value of memory. This is the first step in the agent's functionality. This is the first step. Okay, first step what we are taking is we are updating memory. So this function update memory is doing what? Taking the memory, taking the percept that is being received. So percept is just being received. Memory is already with me of the world. I'm taking these two inputs and I'm producing an update to the memory. So this variable is getting updated, to be very honest. So I'm just updating the memory that I have about the world. Next thing that I'm doing is choose the best action. So based on now the renewed memory, I'm actually trying to figure out what could be the best possible action. So this function is actually the crux of the agent's working. This is going to map the memory to action. Now you'll say that यहाँ पे percept sequence कहाँ हुआ? So just imagine this memory initially would be 0. As I see the first percept, I'll get my memory initialized. As I get my second percept from the previous memory instance and the current percept, I will regenerate new memory instance. So I'm actually memorizing the environment in this particular variable called as memory. So this is how I remember the percept sequence. So this is my way of, or this is the agent's way of remembering the percept sequence. So I'm remembering the percept sequence into this particular variable called as memory. So I'm passing P star here by sending memory and I'm getting best possible action A out of this particular function as an output. So we are doing exactly the same that we wanted to do. Once I know the action, I again try to update the memory using this action because I need to remember ना कि भाई मेरा सब सीक्वेंस ये था और मैंने ये एक्शन किया था. Okay, and that is what I'm adding into the memory. So this is kind of a skeleton that if defined properly would make my agent work rationally or behave rationally. So this I want you to think about it what this is doing. Read the thing which is written over here at the bottom of the slide, which describes this particular skeletal agent program. So although this is a function in programming language interpretation, this is a pseudocode of a function whose name is skeleton agent. Okay, but in terms of agent abstraction, this is the program of agent. These are the steps that the agent would perform in order to be a representative rational agent. Okay, so please understand the small detail in this particular discussion. Although it is a word function used here, and there was something called as agent function used earlier as a term. That agent function was referring to mathematical mapping between percept sequence to action, whereas this one over here is actually realization of that mathematical mapping. That mapping is only done in the second step. Second step में वो P star map to A हो रहा है. But this function, this step and this step, first and the third step, they are letting you make this particular mapping consistent for making the agent behave rationally in the due course of its operation. Okay, the agent is always in interaction with the environment through its percepts. As it receives the percept and it remembers the previous memory about the environment, we update this memory so that we can reconstruct P star percept sequence. So we are reconstructing percept sequence. Okay. Then as I reconstruct percept sequence, then I can choose a corresponding action. There will be some logic for doing it. There will be some implementation that does this particular thing. And always there will be some alternative implementation for this. We will like to have the best possible implementation that makes our agent a rational agent. So this is exactly what comes in the later discussion in this particular chapter. Okay. Yeah, we are taking a single percept as input and we are not taking history. Performance measure is not part of the agent. So agent के पास performance measure नहीं है. Somehow these functionalities that we are going to incorporate, they will take care of this. Okay, they will take care of this. How? We'll come to know that when we discuss the different architectures that make up an agent. Now we'll see that there are 5 different agent architectures mentioned in our syllabus, or they are mentioned in the book as well. Beyond this, there are other agent architectures as well that we will keep on studying further. But if somebody asks you that explain different types of agent architectures, these are the 5 agent architectures that you talk about or that you tell about. Okay, so the first agent architecture is an hypothetical agent architecture. We have seen an instance of this architecture previously, but we'll revisit it once more in these set of slides. So this is called as table-driven architecture. That means you will try to construct a table for every percept sequence mapped to a particular action. So this is a two column table. Left hand column is the percept sequence, and right hand side column is the specific action that you need to perform when that percept sequence is seen. Okay, so table-driven agent is the first and the most simplistic version of mapping between P star to A. Second is simple reflex agent. Third is the model-based reflex agent. So this particular thing, so reflex agent with internal state. This internal state is referred to as a model of changing world. This particular internal state is generally referred to as a model of changing world. That's why this third thing is referred to as a model-based reflex agent. Fourth thing is a goal-based agent, an agent with explicit goals. Now, we as a human being generally are driven by certain ambitions, certain goal sets that we always have behind doing certain activities. Okay, if you want to actually go to a movie, there is always going to be a goal. Okay, so you don't just say that I want to go to a movie, then you go to any movie and you satisfy it. No, you always have certain goal. This week, this particular movie is getting released. It is having this particular couple of actors which are very familiar I am with, or I like to go to their movies and then I want to go to that particular theater. Okay, because it is in this particular vicinity, it has these particular characteristics and all, but always there is some goal. There is some goal that I need to achieve. I can't just go to a certain place and watch a movie. I always have certain kind of explicit definition of if I want to see a movie, I'll see it in this place with these particular people around me, and I'll do all these activities in order to get there. Any other example also in your real world? Say, suppose you are thinking about your career paths, career goals. Okay, then there would be certain family goals, that there could be certain financial goals. So this term goals is pretty much there in human behavior always. Now, agents, if they actually work upon the agent architecture that actually supports a representation and orientation towards achieving a goal, then that is called as a goal-based agent or agents which are having explicit goals. Such agents are generally referred to as goal-based agent. Now, the goal is an abstract thing. Goal is a thing that is not clearly defined or cleanly defined. Whereas utility, on the other hand, gives you a measure of satisfaction, a measure of, say, suppose I'm achieving a goal, I'm not achieving a goal. Okay, that can be determined in goal-based agent. But then utility of being there and being able to achieve a goal with certain mechanism and with certain other mechanism, it will give you a comparative picture of how satisfied you as an agent are when achieving that certain thing using, say, path A or using, say, path B, or say alternative A or alternative B. So utility based agent actually gives you a numerical sense of the happiness or numerical sense of the achievement based on whether and how